is only one perfect solution. There are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb, and today we're going to be taking a look at a fairly tricky module that can require a bit of guessing and checking, Digisibility. So this is the way the module looks, and what we have here is a series of 9 different numbers that can have duplicates present in this case. And what we're going to do is look at is we need to simply rearrange these digits based off of a specific calculation that we have to perform. So I'm actually not even going to show you the manual because the concept of it is really simple. What we're going to do is we're going to go through what I would refer to as stages in this case. And in most of the cases you're looking for one solution. There can be cases where you're looking for multiple solutions, but that rarely happens with this new update. And what we must do is, based off of the order of the numbers, let's note down our order: 721, 728, 917. What we're going to do is we're going to simply rearrange all of our digits present on these displays such that each stage that we go through and each number that we add is divisible by this stage's number in this case. So our first number that we must put down of these numbers must be divisible by 7. So in this case, looking at the numbers that we actually have present, the only number that would be divisible by 7 in this case is 7. So that would actually be guaranteed to be our first number. However, the next stage, the next number has to be divisible by 2. And this is where things get a little bit tricky. Now, you might be asking, wait, can't we just use, for example, 8 or something like that? Well, in this case, we actually could use 8, but what we're not looking at is, instead of just 8 being divisible by 2, we're looking at 78 being divisible by 2. So the numbers will keep expanding each stage, and this is where things can get a little bit tricky. So in this case, we might have either an 8 or a 2 present for this stage. This is where things get a little bit tricky. So we're going to do currently 78, and we're going to divide it by the current stage number that we're on. In this case, the first stage will be divisible by 7, the second stage will be divisible by 2, 1, then 7, then 2, then 8, and so on and so forth. And each number, we will be increasing the number based off of the amount of digits that we have and the current stage. And each number must apply. So this is where things absolutely can get a little bit tricky. So in this case, our next number has to be divisible by 1. So that actually can just simply be a wild card. So that actually can be anything. So we're actually going to leave a question mark on that one. And we'll come back to that in a little bit. So in this case, we have 7, 8, and now our next number needs to be divisible by 7, in this case. So this is actually where we have to try out some different numbers here. So let's try simply 7, 8, 9, and then 7. Let's see if that works. So 7, 8, 9, 7. So let's try and see if this is divisible by 7. In this case, it is not directly divisible by 7. We're not going to use decimals by any point, and if we do get a decimal result, that means the number is not divisible. So let's change up a couple things. So let's actually try and keep the 7 the way it is, and let's actually trade in another number here. So let's try 2 maybe. 7, 8, 2, 7. No, it does not change the way it is. So maybe let's try 1. Nope. Let's try 8. Nope. So that means we likely have a different answer. So maybe let's try, in this case, let's try 2 being the second digit. And we actually do find a solution here. We can do 7, 8, 2, and 7. And just like that, the fourth stage can be applied here in this case. So 1, 0, 4, 1. However, of course, this can be indeed bound to change because of the fact that later digits may actually not be divisible by these numbers being in this order. So let's take a look at the next stage. So the next stage has to be divisible by 2. So since we've already used 2, we can simply use the second 2 that we have, or the 8. So either the 2 or the 8 in this case. Let's try 2. So 2 is divisible by 2 now. And then the next stage, we actually have to be guaranteed to either use 2 or 8. So simply, this is going to be the time where we're going to reorder one of these numbers. Actually, wait a minute. This number actually cannot be 8 because of the fact that we need to divide these guys by even numbers, and even numbers can only be divided by even numbers, not odd numbers. Or rather, odd numbers can never be divisible by even numbers in this case. So actually, this number that we have here, that 8, is not correct. So we actually need to change it for something else. So let's see if we can go back a stage, and we're going to be looking at the 7 again. So it could be very likely that we just need to change this back to 8, and we can simply mess around with this from here. That is a good catch that I caught right there. So we can do perhaps 7, 8, 9, and this actually does mean that our third number and fourth number are guaranteed to be odd numbers. That actually does limit our options here. So 7, 9, let's try 7, 9, 7, 8, 9, 7. Is that divisible by 7? If not, let's maybe try 7, 8, 1, 7. Or maybe 1, 9. Here we go. So 7, 8, 1, 9 in this case actually does work. Since 7, 8, 1 is divisible by 1, and 7, 8, 1, 9, as we can see here, is divisible by 7. This is exactly what I mean by this module can actually be a little bit tricky, because it can these numbers can indeed affect later stages, so it's very important that we pay attention to that. So next up, this is another guaranteed to be an even number, and since we've actually already used the 8, that means we have to be using the 2 for the next stage. So in this case, 7, 8, 1, 9, 2 is indeed divisible by 2. And the next digit has to be divisible by 8 in this case, so 8. And in this case, let's input the last 2 that we have present, and let's see if that is indeed divisible. It is not, so we actually need to reorder this again. So this is exactly what I mean by where this module can actually be really, really annoying. So it's very likely that we have to put the 2 back here, and that actually does indeed change our order a little bit here. So let's go back a few stages. So 7, 2, 1, 9, is that divisible by 7? It's not. 7, 2, 9, 1, perhaps? No. 7, 2, 9, 7. 7, 2, 7, 9. 7, 2, 7, 7. No. 7, 2, 1, 1. Nope. 7, 2, 1, 7. There we go. 7, 2, 1, 7. We can change that now, and that will work for that stage. So now we can do the 2 again, or we can do the 8 here. So let's actually figure this out. So either the 2 or the 8 will make it divisible by 8. So let's do 7, 2, 1, 7, 2 divisible by 2. That works. And then we're going to add the 8 on the end for this last stage. So the 8, and then divide this by 8 in this case. This does ring true. 7, 2, 1, 7, 2, 8 is indeed divisible by 8, which is the 6th stage that we're on. So now let's actually recap of what numbers we have gotten rid of in this case, so that we can actually keep track of what else we need to use in the case. So we've done 2 7s, we've done the 2 and the 1, we've done the 2 and the 8, so we're left with 3 remaining digits, 9, 1, and 7. So let's figure out what we can do here. So 7, 2, 1, 7, 2, 8, 9, is that divisible by 9 in this stage? It is. And then in this case, we can do 1 and then 7. And then lastly, is this 7 divisible by, is this large number divisible by 7? Let's find out. It is indeed in this case. So 1 is divisible by anything in this case, so that's why we put the 1 there. And then lastly, 7. So all of these statements ring true based off of the divisors here, and simply what we can do is actually submit this one in reading order. So 7, 2, 1, 7, 2, 8, 9, 1, and lastly 7. And just like that is a solved module. So that's how this module works. It's essentially what you're trying to do is you're trying to create a large string of digits that each apply to a series of divisors up top. We'll take a look at another example here. So now, already another thing I would like to mention is the fact that there are 5s present. Now, what this means is that regardless of whatever position it is in, the 5s can only have a 5 or 0 in that position. So this already means that this 5 is going to be guaranteed to be in the last position. So now, let's take a look. So in this case, we have 9, 3, 2, 6, 7, 7, 4, 4, 4, or 4, 4, 5 in this case. So our first number is 9. This stage has to be divisible by 9, and thankfully enough, that means that 9 is the only one divisible in this case, because these numbers are too small to actually be divisible by 9. So 9 is guaranteed to be our first number in this case. Next up, we need an answer that is divisible by 3. 93 is indeed divisible by 9, or divisible by 3 in this case, as we can see here. And then we can do 932, which is divisible by 2. And then we can maybe do 9326. Is that divisible by 6? It is not, so we have to actually use something different. Can we use perhaps one of these 4s to get an answer? Yes, we can. So we can just simply substitute this as a 4. Next up, the next stage is going to be divisible by 7. And then we can simply do perhaps a 7 present, and then another 7 present, and both of those 7 do indeed work there. So next up, we have to be divisible by 4 in this case. Can 6 work? It can. So 6 can work in this position. We've already used that. We've used that 6. And then next up, it has to be divisible by 4. In this case, if we can put the 4 there, that should work. It does indeed. So then that means the last digit is guaranteed to be a 5. Because 5 in this case is divisible by 5 as last digit. 5s are the easiest case that you can indeed get, so it's always important to pay attention for those. 5s are guaranteed to be 5s because 0s do not pop up on this module because nothing is, like, you cannot divide by 0, and 1s are basically your wild card, as you can put anything there if you want to. So let's submit this number. So we're going to submit 932, 477, 645. We have 932, 477, and then 645. And just like that is the solved module. Let's take a look at one final example, and I hope you guys are understanding this. But what you're doing is progressively moving from stage to stage, and each of these numbers has to be divisible by the number sequence that we've already built from previous stages. So let's take a look at this final example here. So 659, 128, 437. So our first number has to be divisible by 6. And in this case, none of the numbers here are actually divisible by 6. So in this case, 6 is guaranteed to be used as the first number. And then as we said before, 5s are guaranteed to be 5s. So that's already guaranteed to be there. So 5 will always be in the second position. Next up is 9. 9, we actually have a couple options to use here. We have the 9, the 3, the 7, and also the 1. Let's try a couple examples. So we have 6, 5, and then divide this by 9. And then let's place in simply the 9 there. That actually doesn't work in this case, so we'll have to use another number. Let's try 3. Let's try 7. 7 in this case actually does work. So we can use that 7 for later on. 1, as we mentioned, is our wildcard. However, looking at the next 2 stages, these numbers have to be even. Actually, the next 3 stages, rather. These numbers have to be even, so we're going to use an odd number for this 1. So maybe let's use 9. Let's see if that works. So 6579. So next up, the next stage is going to be divisible by 2, giving us 2, 8, and 4. So let's actually just try doing 2, 8, and 4. So 2, and then the next stage is going to be divisible by 8. We'll put in 8. That works. And the next stage is divisible by 4. Let's do 4. That also works. So then we can do simply 2, 8, 4. And then for our last 2 stages, we have to be divisible by 3. So the ones that we're missing here is currently 1 and 3. So let's try putting in 1. 1 works, and then divisible by 7. If we put in that last 3, it does not work. So we obviously went wrong somewhere. So obviously we need to take a step back and perhaps re-input that 9 as another digit. So let's take a look. So we're going to need to take a step back, and this is exactly what I mean by sometimes it can be a bit tricky to find the exact number that you need, but with the strength of guessing and checking, you should be able to get through it. So let's try, in this case, let's try the 3, and then it hopefully should be able to do the 2, 8, 4. Let's try divisible by 2. Then we add the 8, divisible by 8. Yep. And then 4 divisible by 4. That still works. So now we simply just replace that 9 with a 3. And then lastly, we're left with 1 and 9 in this case. Let's try perhaps the 9, the 3, and we'll put the 9 for that last stage. That is not divisible by 3. Let's try 7. 7 works in this case. So hopefully, our last number, we can simply input... Oh no, we actually can't use the 7. I stand corrected. So let's use the 1 in this case. The 1, however, is indeed still divisible. So, hopefully, the 9 should be able to go and be divisible by 7 for this last stage. So 65732841 hopefully is divisible by 7. It is not in this case, so that means we are looking at another digit. So we have done, for the 4th stage, we have done 3, and we have done 1. We have done 3 and 9, so that means 1 actually has to go here. So let's actually take a step back, because otherwise, then that means we have to take a step back to that 7 in this case as well. Let's take a look at 1 in this case. Let's make sure. So 65712 is still divisible by 2, yes. This should be still divisible by 8, yes. And this should still be divisible by 4. All is fine and dandy for now. So for our last 2 stages, we have to use 3 and 9 in some sort of manner. So let's try 3 divisible by 3, and then we'll use 9 as our last digit. Is that divisible by 7? It is not, so maybe let's reorder it, so 9 in this case, and then 3. That, in this case, does work, so let's take a look back. So this should be divisible by 3. In this case, that does work. And then our last number that we use, in this case being 3, is divisible by 7. Now, this is the order that we have to use the numbers in, as all of these cases did indeed apply to be true based off of the divider of the numbers, and we're going to input the solution. So now, it's important to note that, as we did before, we actually had a reading order solution for that first example, and in this case, we obviously don't have this example. So 657, 128, and lastly, 4, 3.
Not it, I'm afraid.
And no. Or, excuse me, 493. Whoops, I misentered that. I forgot to change the notes. So in this case, 657. And as I just noted there, if you strike the solution, the puzzle does not reset. So 1, 2, 8, 4, 9, and 3. And just like that is a solved module. Hope you guys understand that. It's a little bit of a confusing concept to grasp on, but what you're doing is you're going through each stage, and you're plugging in a number based off of the digits that we have here, which we actually had no duplicates at all in this case. And we're simply rearranging the digits such that each stage is divisible by this length of digits in this case. So, as always, thank you guys for watching. Remember to stay crazy, stay cool, and I'll see you guys in the next one. Bye-bye.